Welcome to a deep dive into the world of real-time object detection. We're going to be looking at a 2016 research paper called You Only Look Once, Unified Real-Time Object Detection.
Oh, yeah.
Now imagine understanding how computers see the world, but like way faster and accurately too. And get this, we're talking 155 frames per second, which is unheard of at the time.
It's truly a landmark paper in computer vision. It really changed the game.
Okay, so before we jump into YOLO, can you paint a picture of what object detection was like before this paper came out?
Picture this. Computers trying to identify objects by scanning tiny sections of an image, one after another. In a sliding window fashion, it was a multi-stage process, super complex, and incredibly slow.
That sounds about as efficient as trying to find a needle in a haystack blindfolded.
Exactly. And that's where YOLO's brilliance comes in. Instead of this piecemeal approach, YOLO simplified things by treating object detection as a single prediction task. Where are the objects, and what are they? It looks at the whole image at once and directly predicts bounding boxes, which are like imaginary rectangles around the objects. They're class probabilities, which basically tell us how confident the system is about what type of object it's seeing.
So it's like taking in the entire scene at a glance, rather than focusing on tiny details one by one.
Precisely, and this shift in thinking allowed for some major improvement in speed and efficiency.
Okay, so walk me through how this actually works. What's happening under the hood?
Think of it like this. A grid is laid over the image, dividing it into cells. Each cell is responsible for predicting objects within its little zone. These predictions come in the form of bounding boxes, potential locations of objects, and confidence scores, indicating how likely it is that an object is actually present.
So it's not just saying, hey, I think there's a cat somewhere in this image. It's more like, I'm 90% sure there's a cat, and it's probably right here in this box.
Exactly. It's providing both location and a level of certainty, and it does this all in one go, thanks to a single neural network that processes the image. No back and forth between multiple stages, just a single pass. You only look once.
That explains the name and the speed. But was sacrificing accuracy for speed a concern?
That's what's remarkable. YOLO managed to achieve this incredible speed without sacrificing too much accuracy. The base YOLO model processes 45 frames per second, which is already real time. But then there's fast YOLO, which can process an astounding 155 frames per second. We're talking less than 25 milliseconds of latency.
That's got to be faster than most human reflexes. No wonder this paper made such a splash.
It definitely shook things up, and it's not just about speed. YOLO also brought this really cool concept of global reasoning to the table.
Global reasoning, what does that even mean in the context of computer vision?
Because YOLO analyzes the entire image at once. It's able to understand the context of the scene much better. For example, it can recognize that a shape in the background is unlikely to be a car if it's partially obscured by a tree. It's almost like it's developing a rudimentary understanding of the world, like we do.
So it's not just identifying individual objects, it's actually starting to make sense
Yeah,
of the relationships between them. That's pretty impressive.
it is. This ability for global reasoning meant that YOLO was much less likely to misinterpret background elements as objects. Compared to previous methods, it was making less than half the errors when it came to background identification.
That's a pretty significant improvement. Are there other advantages YOLO has that we should be aware of?
There's another interesting aspect. Generalization. The researchers train YOLO on natural images, like photos you might find online or in your camera roll. But what's really cool is that YOLO also performed incredibly well on artwork.
Boy, artwork, like paintings and sculptures.
Exactly. Even though it wasn't specifically trained on those types of images, YOLO was still able to accurately detect objects within them. This suggests that it was picking up on some fundamental principles of object recognition that go beyond the specific data sets it was trained on.
So it's like YOLO learned something fundamental about how to see objects, regardless of the style or context. That's a big deal.
It is. And this generalization ability opens up a whole range of potential applications for YOLO, beyond just recognizing objects in photos and videos.
Okay, so we've talked about all the amazing things YOLO can do, but I'm guessing there must be some limitations as well. No system is perfect.
You're right. Every breakthrough comes with its challenges.
So what were some of the hurdles the researchers faced with YOLO?
One limitation is that each grid cell can only predict a limited number of bounding boxes and a single class. So if you have a bunch of small objects clustered together, like a flock of birds, YOLO might struggle to identify them all accurately.
So it's better at recognizing larger, more distinct objects than a jumble of small things.
That's right. It might miss some or have trouble distinguishing between them. It can also struggle with objects that have unusual shapes or configurations that it hasn't encountered much during training.
That makes sense. It's like trying to identify a rare breed of dog you've never seen before. You might mistake it for something more familiar.
Exactly. Another limitation is that YOLO's loss function, which basically measures its errors during training, treats errors in large and small boxes equally. But realistically, a small error in a large box is less important than a small error in a small box.
So if it's off by a few pixels, when drawing a box around a car, it's not a big deal. But those same few pixels could make a huge difference when identifying something tiny, like an insect.
Precisely. So while YOLO is generally very accurate, it can be more sensitive to small errors when dealing with smaller objects.
That's really interesting. So we've talked about YOLO's strengths and weaknesses, but how did it actually stack up against the competition at the time? Were there other systems that performed better?
Now, while YOLO had its limitations, it's important to see how it stacked up against the other leading approaches at the time. Remember we talked about FastRCNN earlier?
Yeah, the system that analyzed images bit by bit.
Right. Well, the 2016 paper showed that YOLO's main source of error was localization, meaning it sometimes struggled to get those bounding boxes perfectly aligned. FastRCNN was better at localization, but it made many more mistakes with background identification, often misinterpreting background elements as objects.
So it was a trade-off. YOLO was faster and better at understanding context, but FastRCNN was more precise with its object boundaries.
Exactly. But here's where things get really interesting. Researchers found that using YOLO to pre-filter the results from FastRCNN actually boosted FastRCNN's performance significantly.
Wait, so by combining the two systems, they were able to get the best of both worlds?
Exactly. YOLO helped eliminate those false positives that FastRCNN was prone to, leading to a much more accurate overall system. It's a great example of how different approaches in AI can work together and complement each other.
So even though YOLO wasn't perfect on its own, it still ended up making a huge contribution to the field.
Absolutely. And this combination even put them among the top-performing object detection methods at the time. But beyond that, YOLO also opened up a whole new world of possibilities with its real-time capabilities.
Right. We talked earlier about how fast it was. But what kind of real-world applications did the researchers envision for YOLO?
Well, one fascinating application they demonstrated was connecting YOLO to a webcam, creating a real-time object tracking system.
So instead of just recording video, the webcam could actually understand what it was seeing.
Yeah.
Identify objects in real time.
Precisely. The paper even mentions that they had a demo of this on their project website. And keep in mind, this was back in 2016. Imagine what's possible now, with all the advancements in AI since then.
That opens up some incredible possibilities. It's like giving computers a whole new way
Yeah.
to interact with the world.
Exactly. And that's what makes this field so exciting. Every breakthrough opens up new doors and leads to possibilities we couldn't have imagined before.
Okay, so we've talked about YOLO's revolutionary approach to object detection, its strengths and limitations, and even how it was used to improve other systems. But what does this all mean for someone like me, who's fascinated by AI, but not a computer vision expert? What's the big takeaway here?
The key takeaway is that YOLO wasn't just about making computers faster at detecting objects. It was a fundamental shift in how we think about computer vision. It demonstrated the power of looking at the bigger picture, of understanding context, and of designing systems that are simple and efficient as possible.
It's like the saying, less is more. By simplifying the process, they were able to achieve incredible results.
Exactly, and that simplicity unlocked a whole new level of speed and opened up a world of real-time applications that were previously impossible.
It's amazing to think how a single paper can spark so much innovation and have such a lasting impact.
It really is. But what's even more exciting is to think about where this technology could go from here.
That's what I was just thinking. If YOLO was this groundbreaking in 2016, what can it do now, given all the advancements we've seen in AI over the past few years?
That's the question that has researchers buzzing, in the years since YOLO's release. There have been several new versions, each building upon the original concept and taking advantage of the latest advances in deep learning. These newer versions are even faster and more accurate, pushing the boundaries of what's possible in real-time object detection.
So we're talking YOLO on steroids then. What kind of impact are these advancements having on the real world?
The applications are pretty mind-blowing.
Yep.
YOLO is being used in self-driving cars to help them navigate. It's being deployed in security systems to identify potential threats and alert authorities. And it's even being used in healthcare to analyze medical images and assist doctors in making diagnoses.
It's amazing to think that an idea that was once confined to research labs is now having such a tangible impact on our lives.
Absolutely, and we're only just scratching the surface. Imagine using YOLO in robotics, enabling robots to navigate complex environments and interact with objects more effectively. Or using it in augmented reality to seamlessly overlay digital information onto our physical world.
It's like we're giving machines a whole new set of eyes to see and understand the world around them.
Exactly. And that's what makes this field so exciting. With every breakthrough, we open up new doors to possibilities we couldn't have imagined before.
This deep dive has definitely left me with a new appreciation for the power of computer vision and the brilliant minds behind it.
It's been a pleasure exploring this with you.
And to our listeners, we encourage you to keep exploring the world of YOLO and the ever-evolving field of AI. Who knows what incredible applications await us in the future?
Until next time, stay curious and keep learning.
This has been The Deep Dive.